Good evening. So last day we started RH criteria. Just I discussed the purpose of RH criteria. So by using RH criteria, we can find the stability. We can find the number of poles in the right of S plane. We can find the range of K value for marginal stability, K value for undamped or marginal stable system, natural frequency of oscillations. We can find even relative stability. These things we discussed in the last day. So now, and one more thing also I discussed. To find the closed loop system stability, we required characteristic equation in what I discussed. To find the closed loop stability, what I discussed, if you want to find closed loop stability, actually we are having 4 stability techniques. The first one is RH criteria. The second one is root locus. Next, Bode plots and Nyquist plots. But when you want to find the closed loop stability by using RH criteria, what I told, required characteristic equation, that is 1 plus G of S H of S equal to 0. Whereas in remain all the stability techniques, if you want to find closed loop stability, required G of S H of S or G of S H of S equal to 1. H of S equal to 1. That means what is G of S H of S is called open loop transfer function of a non-unity or unity feedback system. Unity feedback system. So it is very difficult to draw a root locus diagram or Nyquist plot or Bode plots by using the what? Characteristic equation. That's why we'll use open loop transfer function and then we'll draw the plots. Okay, it will come. What is the difficulty of drawing a plot by using the characteristic equation? But when you want to find closed loop stability using RH criteria, so we required what? Characteristic equation. Be remember. In case system is open loop system, if you are unable to find open loop stability, then required open loop characteristic equation. Okay? Next, up to this we discussed in the last day. Next, listen. Next one. The nth order general form of characteristic equation is, so we want characteristic equation. So the nth order general form of characteristic equation is, what is the characteristic equation? A naught S power n, A1 S power n minus 1, A2 S power n minus 2, and so on. A n minus 1 S power 1, A n S power 0 equal to 0. This is the what? Nth order general form of characteristic equation. So now write the Routh form. Now write the Routh array. Okay, write it. So come on, what is the Routh array? Okay, one more time you can write characteristic equation for your convenience. So here what? A naught S power n. Come on, jaldi, A power S minus 1. Come on, write the Routh stability. Write the Routh array. First of all, what is the necessary condition? Anybody? What is the necessary condition? necessary condition is, so necessary condition is the characteristic equation consists all the coefficients, and all should have same sign. All should have same sign. All should have same sign. So once it is satisfied, so it should consist all the coefficients, all should have same sign. Once it's satisfied, then you have to write the route array. After writing route array, we have to check the sufficient condition. After writing route array, you have to check the sufficient condition. So come on, first write the route array. Write the route array. In case this itself not satisfied, blindly we can say it is not stable. Not stable means it may be marginal stable, it may be unstable. So in case this is not satisfied, so necessary condition itself not satisfied, we can say it is not stable. It may be marginal, it may be unstable. Okay. So now write the route tabular form. S power n, S power n minus 1, S power n minus 2, and so on, S power 0. S power 0. Bolo, S power n coefficient what? A0. A0. S power n coefficient A0. Alternate coefficient. You have to take alternate. So next, S power, this is n minus 2. No? Alternate coefficient. The next what? A2. Next alternate A4. And so on. Next S power n minus 1 coefficient is what? A1. Alternate means A3. A1, A3, A5, and so on. So like this you have to write. Then S power n minus 2 coefficient. S power n minus 2 coefficient. First A1, A2, A1, A2 first. Minus A0, A1, A3. Minus the second one. A0, A3 divided by A1. So come on, write it. A1, A2 minus A0, A3 divided by A1. Divided by A1. Divided by A1. So A1, A2 minus A0, A3 divided by A1. Okay, na? Okay, na? Next. Similarly, second one you find it. Next what tell? A1, A4 like this. All the products with first column only. A1, A4 minus A0, A5 minus A0, A5 divided by what? A1 only. So A1, A4, A1, A4 minus A0, A5, A0, A5 divided by A1 only. Divided by A1 only. A1, A4 minus A0, A5 divided by A1 only, and so on. So here also and so on. So all the products with only first column, be remember. All the products with only first column. So like this you have to go on right. Then finally S power 0 coefficient. What is S power 0 coefficient tell here? An. That will come here as it is. An will come as it is. S power 0 coefficient An, that will come here as it is. S power 0 coefficient An, it will come as it is. Okay, na? Like this you have to write the route tabular form. Okay. Next, when the system is stable, tell what is the condition? Sufficient condition we can say. Sufficient condition or condition for stability. Sufficient condition or condition for stability, whatever it is. Come on, tell. So when the system is stable, all the coefficients in the first column should have same sign. All the coefficients in the first column should have same sign. All may be positive or may be negative. Then we can say given system is stable. In case any sign change occurs, for example here, +2 - 1, -2 +2, Again plus 2 minus 3. That means 3 sign changes. System is what? Unstable. If any sign change occurs, we can say system is what? Unstable. We can say system is unstable. So what is the condition for stability? All the coefficients in the first column should have same sign. All the coefficients in the first column, first column should have same sign. First column should have same sign. All the coefficients in the first column should have same sign. Okay, same sign. And no coefficient should be 0. So there should not be any missing coefficient in the first column. And no coefficient should be 0. No coefficient should be 0 in the first column. No coefficient should be 0 in the first column. If any sign change occurs, the system is unstable. If any sign change occurs, if any sign change occurs, then the system is stable. Then the system is stable. If any sign change occurs, then the system is stable. No. The system is unstable. If any sign change occurs, the system is unstable. The number of sign changes equal to number of poles in the right of S plane. The number of sign change equal to number of poles in the right of S plane. Number of poles in the right of S plane. Number of poles in the right of S plane. Right half of S plane. Okay, na? So if no sign change, if all the coefficients in the first column same sign and there no coefficient should be 0, then we can say system is what? Stable. In the first case, this is the condition for stability. Then we can say given system is stable. All the coefficients in the first column should have same sign and no coefficient should be 0. Then we can say system is stable. If any sign change occurs, then the system is unstable. The number of sign changes equal to number of poles in the what? Right of the S plane. Okay? Okay, na? Right. Right. Next one. Okay. So now we'll solve the problems. Okay. First, not the problem. Identify the stability to the given characteristic equation. Identify the stability to the given characteristic equations. First one, S plus 10 equal to 0. Second one, S square plus 25 equal to 0. Third one, S square plus 10S plus 10 equal to 0. Fourth one, S cube plus 5S square plus 8S plus 20 equal to 0. Fifth one, S cube plus 3S square plus 7S plus 100 equal to 0. Sixth one, S cube plus 9S square plus 4S plus 36 equal to 0. 4s plus 36 equal to 0. Come on, do it, Guruji. Come on, Guruji. Come on. You can do it. Second marginal stable, very good. Third stable, very good. Stable, marginal stable, stable. Good. Come on, Guruji. Do it. Fourth stable. Listen here. All of you listen. So here, first one will take characteristic equation, first bit. What is the characteristic? General form of characteristic equation I'll take. That is AS plus B equal to 0. If I take general form of characteristic equation in terms of ABCD, so that is AS plus B equal to 0. AS plus B equal to 0. If I write a Routh tabular form, this is S power 1, this is S power 0. So S power 1 coefficient A, there is no alternate term. S power 0 coefficient B. A first order characteristic equation having two coefficients A and B. A first order characteristic equation having two coefficients A and B. So both the coefficients lies in the first column only. Both are lies in the first column only. Both A and B either greater than 0 or less than 0, then the system is stable. Then the given system is stable. Both should have same sign. Both should be either greater than 0 or both should be either less than 0. The given system becomes stable. If I take a second, in case if I take a second order characteristic equation, in case I'll take a second order characteristic equation, that is AS square plus BS plus C equal to 0. AS square plus BS plus C equal to 0. If I take a second order characteristic equation, now tell, if you write a Routh tabular form, this is S square, S power 1, S power 0. What is S square coefficient? A. Alternate term C. So next S power 1 coefficient B. S power 1 coefficient B. Yes or no? S square coefficient A. Alternate term C. S power 1 coefficient B. S power 1 coefficient B. Next, no alternate term means you can write even 0 also. Nothing wrong. Now what I will get tell here? Bolo BC minus 0. First this to na BC minus 0. So BC minus 0 divided by B. That means what I am getting? BB cancel. What I am getting? C. Yes or no? C. That means what you observed here? In the first column, what are the coefficients are there? A, B, C. So second order, what are the coefficients are there? A, B, C. That means what happened? Whatever the ABC there in the second order characteristic equation, all the terms lies in the first column. All the terms lies in the first column. That means what is the conclusion tell? All the three coefficients A, B, C, either greater than 0 or all the three coefficients either less than 0, the given system becomes stable. All should have same sign. All should have same sign. A, B, C, all should have second order equation. All should have same sign. Then we can say it is stable system. In case in second order equation, listen, second order equation, in case B equal to 0, A comma C, either greater than 0 or less than 0, the given system becomes marginal stable. MS means marginal stable. The given system becomes marginal stable. If B equal to 0, A comma C, greater than 0 or less than 0, then the given system is marginal stable. Why? Because In case B equal to 0, here, what is the characteristic equation? Tell. B equal to 0. What is the characteristic equation? AS square plus C equal to 0. Then find S. S equal to plus or minus J root C by A. S equal to plus or minus J root C by A. That means what you are getting? The poles lies on the what? Imaginary axis. The poles lies on imaginary axis. The system becomes the what? Marginal stable. The system becomes the marginal stable. That means what is the conclusion? First one is 100% stable because first order, both are having same sign, 100% stable. Second order, second one, B is 0. That means it is a marginal stable. Marginal stable. Third one, all the coefficients having same sign. Here no coefficient means 1 plus 1 plus 10 plus 10. All are same sign. Blindly we can say stable system. So similarly, you take a third order system. Similarly, you take a third order system and then get the answer. Come on, come on. Why previous slide, man? Take screenshot. Take screenshot. Previous slide you are telling. Take it. Right. Next. Okay, yeah. Sign change, then it is unstable, no doubt. Next. Come on. Get the screenshot who want it. Don't ask previous slides. At the end, we'll see anything you want. Okay. Right. 4F. Next. Third order system you take. Third order means what is the fourth one? So this is the fourth equation. So third order system will take fourth one. I'll take a third order system like AS cube plus BS square plus CS plus D equal to 0. AS cube plus BS square plus CS plus D equal to 0. Now similarly solve it. You solve the same way, you will get the condition for third order system. So this is S cube, S square, S power 1, S power 0, S power 0. Now come on, get the answer. So S cube coefficient is A, alternate is C, alternate C. S power 2 coefficient is B, S square coefficient, alternate is D. Now get the S power 1 coefficient, come on, get the S power 1 coefficient. S power 1 coefficient, you get it. S power 1 coefficient, bolo BC, BC minus AD by B. BC minus AD by B. BC minus AD by B. So now S power 0 coefficient is D. S power 0 coefficient is D. S power 0 coefficient is D. Okay. S power 0 is D. Now get the answer. Come on. So why D means, see, this S power 0 coefficient, whatever is there, that will come as it is here, or it can shift diagonal, or this is 0 na. Now tell this total I consider, for example, X. So this total I consider X. Now tell XD minus 0 by X. What is the answer? Tell XD minus 0 by X. X's cancel. Then what is there? D. That only I written here. That only I written here. Okay. Now tell when the system is stable. Tell when the system is stable. So first step, the D must be greater than 0 for stability. The second step, this product term must be greater than 0 for stability. So greater than 0 for stability. D must be greater than 0. BC minus AD must be greater than 0 for system stability. That means what is the condition for stability? Tell. What is the condition for stability? For stability, what is the condition? First one, D greater than 0. Second one, BC minus AD greater than 0. Divided by means same na. BC minus AD must be greater than 0. That means what happened? BC must be greater than AD. Then the given system is what? Stable. Then the given system is stable. Stable means what? All the three poles lies in the left of S plane. All the three poles lies in the what? Left of the S plane. All the three poles lies in the left of the S plane. In case I'll make equal to 0. In case I'll make here equal to 0. Equal to 0. In case if I make equal to 0, then it is marginal stable. Or if it is less than 0, in case it is less than 0, the system become unstable. Less than 0 means unstable. Less means what? Less than 0 means negative. Negative means here you will get the negative sign. If you get the negative sign, how many sign changes here? Positive is there, na? So positive to negative, one sign change. Again negative to here, positive na, greater than 0 na here. So two sign changes you will get. The system become unstable. So that means what is the condition for unstable? Tell. What is the condition for unstable? BC minus AD by B should be what? Less than 0. That means what is the condition? Tell. BC less than AD. The given system is what? Unstable. Wow, how many sign changes we got? Two sign changes. That means what? Two poles lies in the right of S plane. Two poles lies in the right of S plane. Only one pole lies in the what? Left of the S plane. Only one pole lies in the right of the, one pole lies in the what? Left of the S plane. Total three poles only na. Two sign changes. Two poles right. Two poles right. Two poles right of S plane. One pole only left. In case I'll make equal to 0. In case I'll make equal to 0, then it is marginal stable. In case I'll make equal to 0, then it is marginal stable. Marginal stability, MS. So equal to 0, marginal stable. That means BC minus AD equal to 0. Then it is marginal stable. That means BC equal to AD. Then the system is what? Marginal stable. BC equal to AD, then it is marginal stable. In this case, the poles placed on the imaginary axis. In this case, the poles placed on the imaginary axis. In this case, the poles placed on the imaginary axis. The poles are placed on the imaginary axis. Imaginary J omega axis. The poles placed on the J omega axis in this case. Two poles on imaginary. One pole should be left hand side. So one pole should be left hand side. One pole should be left hand side. What are that imaginary pole location means? So for up to third order system, we can find stability directly. Up to third order system, we can find stability directly. We can find stability directly. Be remember. Up to third order system, we can find stability directly. So how to write the stability means here? So how to write stability means just make even power of S terms 0. Make even power of S terms 0. Even power of S terms 0. For frequency of oscillations, we can say even frequency of oscillation. Even power of, it is valid for only third order system. It is valid for only third order system. Even power of S terms equal to 0. Even power of S terms equal to 0. So it is valid for only third order system. Even power of S term 0. What are the even power of S terms? Tell. Even power of S terms tell. BS square plus D equal to 0. So that means find the S value. S equal to what? Plus or minus J root of D by B. S equal to plus or minus J plus or minus D by B. That means this is plus J root of D by B. This is minus J root of D by B. The system becomes marginal stable. That's all. This is about the third order system. Simply what is BC here? Tell. What is BC? Anybody? What is BC? What is AD? BC is a internal product. Listen here, carefully listen. So what is BC means? Simply BC is a internal product. BC is a internal product. AD is a external product. AD is a external product. BC is internal. AD is a external product. Internal product greater than external product stable. Internal equal to external marginal stable. Internal is less than external, then it is unstable. But be careful that all the coefficients should have same sign. This is valid only all the coefficients having same sign. In case any sign change is there, blindly we can write it is not a stable system. In case any sign change is there, you can say blindly it is a not stable system. Now come to the this question. Come on. Internal product how much? 8458 40. Yes or no? External product 20. Internal is greater than external. 40 greater than 20. That means the given system is stable. Here internal product 21. External product 100. Internal is less than external. Internal is less than external. That means the given system is unstable. The given system unstable. Internal product 36. External product also 36. Internal equal to external. 36 equal to 36. Then the given system is what? Marginal stable. The given system is what? Marginal stable. So if find frequency of oscillation, if you want, even power of S term 0. 9s square plus 36 equal to 0. So frequency of oscillations you want. So even power of S term 0 means 9s square plus 36 equal to 0. So 9 4 ja. S equal to what? Plus or minus J2. S equal to plus or minus J2. So that means frequency of oscillations is omega n. We can say omega n is 2 radians per second. Omega n is 2 radians per seconds. Like this, you can find the what? Frequency of oscillations. Okay, na? Even power 9s square plus 36 equal to 0. S equal to J2. Then we can say 2 radians per second is the frequency of oscillations. Okay, na? Right, very good. Very good. Right. Next problem. Find the number of poles. Next problem. Find the number of poles. Up to third order system, we'll write answer directly. Up to third order system, we'll write answer directly. Up to third order, we'll write directly. Okay, na? Okay, na? So first and second order, just we'll observe the signs. All are same sign in the characteristic equation table. Third order, internal and external product. Priyanka, what is the doubt? Priyanka. Right. Next. Right. Find the number of poles in the right of the S-plane. Find the number of poles in the right of the S-plane. To the following characteristic equation. Come on. S power 4 plus 2s cube plus 3s square plus 4s plus 5 equal to 0. Come on, do it. Get the answer, Guruji. Priyanka Gudikandula. Tell any doubt? Hello? 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 Right. Come on, get the answers. 2 poles in the right. Right. Characteristic equation. Come on, write it. This is S power 4, S cube, S square, S power 1, S power 0. So then 1, next alternate 3, next alternate 5, next 2, alternate 4. 2, 4. Next. So listen here. Listen. S power 0 coefficient, whatever is there, S power 0 coefficient is fine. This S power 0 coefficient. For in any problem, it is valid for all the problems. It is valid for all the problems. This S power 0 coefficient, just shift the diagonally. Shift the diagonally. Shift the diagonal. Just shift the diagonally by leaving one row before one column. Shift the diagonally by leaving one row before one column. Before one column. So shift the diagonally, just shift the diagonally by leaving one row before one column, before one column. Similarly, leave one row before one column, before one column. S power 0 coefficient. S power 0 coefficient, whatever is there, S power 0 coefficient, F5. Shift the diagonally, leave one row before one column, leave one row before one column. Or in even power of S power rows, even power of S power rows, S power 4 even power, last coefficient should be S power 0. S square, last coefficient should be S power 0. S power 0, S power 0 coefficient. Simply shift the diagonal, leave one column, shift the S power 0 coefficient, observe in the characteristic equation. S power 0 coefficient, observe in the characteristic equation. Shift the diagonal, leave one row, shift the diagonal, leave one row, one column before, that's all. Now, how many coefficients you have to find? 2 coefficients. Come on, find it. 2 into 3, 6. 6 minus 4. 6 minus 4. Yes or no? 6 minus 4, 2. 2 by 2, 1. Next, come on. 1 into 4, 4. 4 minus 10. That means what? Minus 6. Minus 6 by 1 means minus 6 only. Correct, na? Now tell how many sign changes. So positive to negative, one sign change, negative to positive, another sign change. That means 2 sign changes. 2 sign changes. 2 sign changes. The given system is unstable. How many poles right? Tell. 2 poles lies in the right of S plane. 2 poles lies in the right of S plane. In the right of S plane. Right of S plane. 2 poles lies in the right of S plane. Total how many poles? 4 poles. So remain 2 poles where? Lies in the left of S plane. 2 poles lies in the left of S plane. Remain 2 poles lies in the left of S plane. That's all. Next problem. Come on, solve it. Characteristic equation. S power 4, 2S cube plus 3S square plus 2S plus 1. Little bit down, I'll write. S power 4, 2S cube, 3S square plus 2S plus 1. Come on, solve it. Come on, solve it. So write the Routh tabular form. This is S power 4, S cube, S square, S power 1, S power 0. Come on. S power 4 coefficient 1, alternate 3, alternate 1. Next S cube coefficient 2, next alternate 2. S power 1 also 2. Now get the answer. Come on. S power 0 coefficient is 1. This 1 shift the diagonally. By leaving one row, shift the diagonally. That's all. Like this. Shift the diagonally. It is all the problems. Same procedure. We'll shift just diagonally, irrespective of the order. Next, S square coefficient. 6 minus 2. 6 minus 2 means what? 4. 4 by 2 means 2. 4 by 2 means 2. 2. Next, 4 minus 2. 2 into 2, 4. 4 minus 2, 2. 2 by 2, 1. So, no sign change. Na? No sign change. No sign change. No sign change. That means given system is what? Stable. No pole in the right. No pole in the right. No pole in the right. So 4 poles left. 4 poles in the left. 4 poles in the left. That's all. Next problem. Next problem. Completed na? Next problem. Characteristic equation. Come on, do it. S power 4 plus 2s square plus 3s plus s plus 2 equal to 0. Come on, Guruji, come on. Stable. Here s cube. Make it correct. Here s cube, here s square. S power 4 2s cube plus 3s square plus s plus 2. Come on, Guruji. Unstable, stable, unstable. Find number of characteristic equation you write. You write the Routh tabular form. S power 4, S cube, S square, S power 1, S power 0. 1, alternate 3, alternate 2, next 2, next 1, next 1. Now get the answer. Come on. Come on, get the answer. S power 0 coefficient. Shift the diagonal. This is shift the diagonal. Shift the diagonal. Shift the diagonal. Shift the diagonal. S power 0 coefficient. Shift the diagonally. Shift the diagonal. So next, come on. S square coefficient. So what I will get here? 6. 6 minus 1. 2 into 3, 6. 6 minus 1, 5. So 5 by 2. Here I will get 5 by 2. 5 by 2. Next, 5 by 2 into 1. So 5 by 2. And 5 by 2.5. 2.5 into 1, 2.5. 2.5 minus 4. So minus 1.5 means minus 3 by 2. Divided by this means minus 3 by 5. Minus 3 by 5. That means how many sign changes we are getting here? Tell. two sign changes we are getting. Two sign changes. Two sign changes. Two sign changes. The given system is unstable. The given system unstable. Two poles lies in the right. Two poles lies in the right. In the right. Remain two poles left. So two poles lies in the left. Two poles lies in the left. Two poles lies in the left. Two poles right, two poles left. Next question. Next characteristic equation. S power 4 plus 2s cube plus 2s square plus 4s plus 8 equal to 0. Come on. Are you solved all the problems in the time domain analysis volume 1? Volume 1 problem solved? Volume 1 problems. All the poles lies in the left of S plane. Next, come on. Stable. No, sir. Not solved. When you will solve? Yes, sir. Solved. Very good. Aditya solved. Some people not solved. When you will solve, Guruji? Come on, come on. Completed all of you? Right, listen. At least tomorrow all day, na? I think tomorrow all day, na? Saturday, I think tomorrow. So, Sunday will solve compulsory. So, you try to complete all the problems by Sunday. Okay. Now, come on. Get the answer. S power 4, S cube, S square, S power 1, S power 0. Now 1. Next alternate 2. Next alternate 8. Next 2. Next alternate 4. Next alternate 4. Now come on. This 8 shift the diagonally. 8 shift the diagonally like this. 8 shift the diagonally. You shift the diagonally. 8 you shift the diagonally. Next, come on. So S square coefficient. What happened? 4 minus 4. 4 minus 4 means 0. We got 0. But there should not, if it's 0 you are getting, next coefficient become infinity. Next, for example, 0 minus 16 by 0 means what happened? Infinity. So next you will get the infinity. Then we cannot continue. You will get undefined. You will get the undefined. That is the problem. That's why whenever you are getting a 0 in the first column, whenever you are getting a 0 in the first column, you should replace it by epsilon. You should replace it by epsilon. Whenever you are getting 0 in the first column, you should replace by smallest positive constant. Smallest positive constant epsilon and continue the Routh stability. It should replace by smallest positive constant epsilon and continue the Routh stability. Come on, next write the Routh stability. So 4 into epsilon. So 4 epsilon minus 16 divided by epsilon. Divided by epsilon. 4 into epsilon minus 16. 4 into epsilon minus 16 divided by epsilon. Then after continuing, then you have to substitute epsilon equal to 0. So you have to substitute epsilon equal to 0 and you have to check the sign change. And we have to check the sign change. That means what you are getting tell. So here 4 epsilon minus and what I can write? 4 minus 16 by epsilon you can write na. 4 minus 16 by epsilon. Now substitute epsilon tends to 0. You have to substitute epsilon tends to 0. That means what is the answer you are getting? 4 minus 16 by 0 infinity minus infinity. 4 minus infinity is minus infinity. That means this is negative sign. This is positive. This is positive. That means what happened? Year to year, one sign change. Year to year, another sign change. So that means what you are getting? Two sign changes. Two sign changes. Two sign changes. The system is what? Unstable. The system is unstable. Two poles right and two poles left. Two poles right. Two poles are right. So simply two poles right and two poles left. And two poles left. And two poles left. That's all. So like this, we have to get the answer. Like this, you have to get the answer. That means what is the conclusion? Whenever any one element is 0 in the first column, replace 0 by smallest positive constant. Listen. Listen. Note. Whenever any 0, any one element is 0 in the first column, 0 in the first column, then replace 0 by, then replace 0 by smallest cause, replace 0 by smallest positive constant, replace 0 by smallest positive constant, that is epsilon. Epsilon. So replace 0 by smallest positive constant epsilon and continue the Routh stability. And continue the Routh stability. Routh stability. Finally, substitute epsilon equal to 0. Finally, substitute epsilon equal to 0 and check the number of sign changes. And check the number of sign changes. And check the number of sign changes. Check the number of sign changes. That's all. So if any one element is 0 in the first column, then replace 0 by smallest positive constant and continue the Routh stability. Finally, substitute epsilon 0 and check the number of sign changes. What is the meaning of what happened when you replace 0 by epsilon? If you are replacing, actually we got 0. 0 we are replacing by epsilon. So what happened? If we replace 0 by epsilon, what happened? So what happened? The pole locations are slightly changed. When you replace 0 by epsilon, listen. So what happened? When you replace 0 by epsilon, the pole location slightly changed, but region is not going to be changed. When you replace 0 by epsilon, when replace 0 by epsilon, the pole location slightly change. The pole locations are slightly changed. Changed, but not the region of the poles. Region of the poles not changed. That means left side pole is left only, right side pole is right only, but not the region of the poles. Region of the poles. For example, if the poles lies here, what happen? 2 poles lies right, 1 pole lies left. So this pole location slightly changes, very slight changes, very slight changes. So it is not that jump left side to right or right side to left. The poles never jump from right to left. Slight, very slight movement will be there. That's all. Okay, na? Next question. Come on, solve this question, all of you. Next characteristic equation, s power 5 plus s power 4 plus 2s cube plus 2s square plus 3s plus 15 equal to 0. Come on, do it. We have 2 classes from 1 to 9 p.m. After that, we are tired and revise the topics. We want 2 days holidays so that we can come back track. Very good desire. Right. 2 days holidays. 2 days holidays. If you give syllabus, it won't complete. You should get the time. You write the schedule, then it came to know how much time you are wasting. Morning, get up and you take your notes for every 1 hour. For every 1 hour, you write the schedule. What you did last 1 hour. And check it how much time you are wasting. So, don't search for the regions. Try to get the solution. You should get the time, that's all. If you think you will get it. 1 day, all day, okay, enough. This is the November, not the June or July, na? Right. Once syllabus complete, then you can get the answer. 2 poles right. Tomorrow all day only, na? Diwali tomorrow all day. Real Deepavali will come only when you success in the life, man. Physical Deepavali, many things will come. Every year it will come, Deepavali. What is there? Deepavali every year will come. You already celebrated many Deepawalis. Maybe 25 Deepawalis are over. If you miss one Deepavali, nothing happens. You want real Deepavali, na? Real success. Deepavali is symbol for success. Try to get that first. So that real Deepavali will come to you. Come on, solve this. S power 5, S power 4, S power 3. Come on. All the students should solve. Only some students only telling the answer. S square, S power 1, S power 0. Even doubts also. Only 3-4 students are asking. Remain students, they never ask doubts also. 1, 2, next 3, next 1, next alternate, 2, next alternate, 15. Come on, get the answer. What is the answer? 2 minus 2, 0. 1 into 3, 3. 3 minus 15 means minus 12. Now 0 replaced by epsilon. Next, come on. 2 epsilon. Here 2 epsilon. Minus of minus means plus 12 by epsilon. Then S power 0 coefficient. Shift the diagonally. Here 15. Here 15. Leave 1 column before 1 column. Leave 1 column before 1 column. Leave 1 row before 1 column. Leave 1 row before 1 column. Now get the s power 1 coefficient. Come on. S power 1 coefficient. So what it is tell? 2 epsilon plus 12 by epsilon. Is it positive or negative? If substitute epsilon 0 is positive or negative? Positive. For example, I'll take this is plus a. Instead of writing total term, I'll take it plus a. It is a positive. And now get minus 12a minus 15 epsilon divided by a. Now simplify this. What is the answer? Substitute epsilon tends to 0. Epsilon tends to 0 means this will become 0. Then minus 12a by minus 12a by a. So what is the answer? Minus 12. Minus 12. So what happened? This is negative. This is positive. So positive to negative, one sign change. Again, negative to positive, one sign change. So two sign changes. Two sign changes. Two sign changes. The given system is unstable. So two poles lies in the right of S plane. Two poles lies in the right of S plane. So remain how many? Total fifth order system. 2 if you write means remain 3 poles lies in the left of S plane. 3 poles lies in the left of S plane. 3 poles lies in the left of S plane. Very good. Right. Right. Next problem. Come on, Guruji. Next problem. S power 5 plus S power 4 plus 3S cube plus 3S square plus 2S plus 2 equal to 0. Come on, solve it. Right. Marginal stable. Very good. After 1 or 2 days, they'll put the control system full day. Yeah, I think 15th or 16th onwards, 13th or 14th, 15th, I think. So they'll, I think control system full day will be there so that it will complete. Okay. So right. Come on. S power 5, S power 4, S cube, S square, S power 1, S power 0. And now get the answer. So this is 1, alternate 3, alternate 2. So 1, alternate 3, alternate 2. Now get the answer. Come on. So what happened? 1 into 3, 3. 3 minus 3, 0. 1 into 2, 2. 2 minus 2 again 0. So here also 0. That means what happened, tell here? What happened? Entire row become 0. Entire row become 0. So we got here row of 0. Row of zeros. We got one row of 0. First row of 0. We got the row of 0. So row of 0 we got. Then what you have to do? When you get the row of 0, what you have to do? What you have to do when you get the row of 0? When you get the row of 0, what you have to do? Very good. So right. Listen. When you get the row of 0, what happened? Listen. Row of 0 occurs means the poles are symmetrical about the origin. That is secondary. First, when you get the row of 0, we should not replace epsilon. Why? Because row of 0 is there, means there is a chance that you may get a poles on imaginary. So when you replace epsilon, for example, replace here epsilon, the position of pole slightly changes. That means the imaginary pole may shift to the right or left. That is the problem. That's why we should not replace by epsilon. We should not replace by epsilon. So what you have to do? You have to go by another concept. What is that? We have to go by another concept. What is that mean? We have to form the auxiliary equation. We require to form the auxiliary equation by using the above the row of 0 coefficient. Form the auxiliary equation. So what is the auxiliary equation? Tell. Auxiliary equation is 1 s power 4. This is s power 4 na 1 s power 4. Alternate coefficient na. So 3 s square plus 2 equal to 0. Plus 2 equal to 0. 1s power 4 alternate 3s square alternate plus 2 equal to 0. Then differentiate auxiliary equation with respect to s. Differentiate auxiliary equation with respect to s and find. So come on, differentiate it. What I will get earlier? 4s cube plus 6 4s cube plus 6s power 1 equal to 0. 6s power 1. Now s cube coefficient replaced by 4. S power 1 coefficient. S cube coefficient replaced by 4. S power 1 coefficient replaced by 6. And continue the Routh stability. So this is by the procedure. But the simple logic, what I want to say that the simple logic is, listen, the simple logic is, this is s power 4 na, this is s square na, this is s power 0 na. Replace 0 by power into coefficient. Replace 0 by just power into coefficient. 4 into 1, 4. 2 into 3, 6. 0 into 2, 0. That's all. So they go s power 3 coefficient 4, s power 1 coefficient 6. Just replace 0 by power into coefficient. 4 into 1, 4. 2 into 3, 6. 0 into 2, 0. And continue the Routh stability. Okay, na? Replace 0 by power into coefficient. 1 into 4, 4. 2 into 3, 6. 0 into 2, 0. Continue the Routh stability. Come on, then do it. What will get here? 12. Next, what will get? 4 into 3, 12. 12 minus 6, 6. So 6 na? 6. So 6 by 4 means 3 by 2. 3 by 2. Yes or no? 12 minus 6. So 6. 6 by 4. 3 by 2. Next, this s power 0 coefficient shift the diagonally. So that means 2. Here also 2. Here also 2. Next, again, what happened? So 3 by 2 means 1.5. 1.5 into 6 means 9. 9 minus 8, 1. So 1 by 3 by 2 means 2 by 3. 2 by 3. That means what happened? All the coefficients in the first column positive. Now what is the system? So whenever, be remember, it is not stable. Don't say it is stable. All the coefficients in the first column positive. Don't say it is stable. Some students stable. Very good. Marginal stable. So don't say it is stable. Whenever row of 0 occurs means forget about the stability. Stability gone, that's all. Row of 0 occurs means stability gone. It may be marginal stable, it may be unstable. Row of 0 occurs means row of 0 occurs. Then system is not stable. System is not stable. Not stable. That means it may be marginal stable, it may be unstable, but it never becomes the what? Stable. It never becomes the stable. Row of 0 you seen means first you should say it is not stable. That's all. It may be marginal stable, it may be unstable. And one more thing here, when the row of 0 occurs in the Routh tabular form means whenever poles lies symmetrical about the origin. Row of 0 occurs means the poles must lie symmetrical about the origin. Poles should be symmetrical about the origin. Symmetrical about the origin. About the origin means what? It may be on the real axis like this. It is also symmetric, or it may be imaginary axis like this. Now also it is what? Symmetrical about the what? Origin. Or there may be repeated poles on the what? Real axis which are symmetrical about origin, or there may be repeated poles on the imaginary axis which are symmetrical about the what? Origin, or there may be complex conjugate poles also. There may be complex conjugate poles which are symmetrical about the origin, which are symmetrical about the origin, which are symmetrical about the origin, which are symmetrical about the origin. So like this. So row of 0 occurs means the poles must be symmetrical about the origin. Row of 0 occurs means row of 0 occurs means means poles are symmetrical about the origin. Poles are symmetrical about the origin. Poles are symmetrical. Poles are symmetrical about the origin. Poles are symmetrical about the origin. Poles are symmetrical about the origin. Row of 0 occurs means poles are symmetrical about the origin. How many poles symmetrical about origin means that gives the order of the auxiliary equation. The order of the auxiliary equation gives the number of poles symmetrical about the origin. Order of auxiliary equation. Order of auxiliary equation gives the number of poles symmetrical about origin. Order of auxiliary equation gives the number of poles symmetrical about the origin. Number of poles symmetrical about the origin. Symmetrical about the origin. What is the order of auxiliary equation? Fourth order. So that means what? 4 poles symmetrical about the origin. The roots of auxiliary equations are poles only. The roots of auxiliary equations are poles. Roots of auxiliary equations are poles which are symmetrical about the origin. Poles which are symmetrical about the origin. 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 Roots of auxiliary equation are poles which are symmetrical about the origin. Which are symmetrical about the origin. Find the roots for auxiliary equation. What is the auxiliary equation? Tell. S power 4 plus 3s square plus 2 equal to 0. This can be written as what? S square plus 1 and s square plus 2 equal to 0. This is like s square plus 3s plus 2 na. So s plus 1, s plus 2. So then find roots. S equal to what? Plus r minus j1 comma plus r minus j root 2. So now represent the poles in the S plane. 0, j omega real. Represent the poles in this plane. One pole is plus j1, another pole minus j1, one pole plus j root 2, another pole minus j root 2, and one pole is left. Total 5 poles, na? One more pole is left. The system is what? Marginal stable. System is marginal stable. Non-repeated poles on imaginary axis. Non-repeated poles on j omega axis. So system is marginal stable. Non-repeated poles on j omega axis, system is marginal stable. So the given system is marginal stable. ठीक है ना? Very good. Marginal stable. 3 poles. 3 poles, how it is imaginary? 4 poles on imaginary. 1 pole in the left. Very good. Right. So, listen here. For example, auxiliary equation order is 6th order. How can you find the roots? How can you find the stability? It is very difficult. Then how to find the stability? So listen here. First of all, I'll write this is difficulty 1 actually. Listen. What is here explained? This is called difficulty 1. This is difficulty 1. Difficulty 1. Difficulty. One element is 0, I discussed now. That is called first difficulty. Difficulty 1. Whenever only one element is 0, we cannot proceed the route stability. That is a difficulty 1. This is a difficulty 2. Rho of 0 is a difficulty 2. What is the difficulty 2? Difficulty 2. Whenever rho of 0 occurs, whenever rho of 0 occurs in the Routh tabular form, in the Routh tabular form, then required to form the auxiliary equation, then required to form the auxiliary equation. Auxiliary, AE means auxiliary equation, by using above the rho of 0 coefficient, by using above the rho of 0 coefficients, rho of 0 coefficients, and differentiate auxiliary equation, and differentiate auxiliary equation with respect to S, and replace the zeros by, and replace the 0 by the coefficients of, by the coefficients of differential auxiliary equation. Differential auxiliary equation, and continue Routh stability. And continue Routh stability. Routh stability. And continue Routh stability. That's all. This is difficulty 2. This is difficult. Whenever rho of 0 occurs in the Routh tabular, that only we did not. That is standard procedure. This is standard. Why I written this standard procedure? Simply we are following the shortcut. So replace 0 by power into coefficient. Simple shortcut we are following. But why I written means in the IS especially, sometimes they are asking even theory questions in the GATE also sometimes. Rho of 0 occurs in the Routh tabular form, then they used to give statements. So required to form auxiliary equation and differentiate, like that statements they are giving. That's why you should know this statement also. That's why I written this. Okay, na? And one more thing here. Already I told row of 0 occurs means poles should be symmetrical about origin. How many poles means that is given order of auxiliary equation. Already we find, then we written system is marginal stable. Now, if order of auxiliary equation 6th order, 8th order, then it is very difficult to find the what roots. We cannot find the roots like this. Then we cannot find the stability because there may be poles on the real axis also which are symmetrical. That's why how to find either system marginal stable or unstable means listen. Listen all of you. It is very important. Listen. What is the meaning of row of 0? Row of 0 occurs means what? Row of 0. Row of 0 occurs means what? Row of 0. One time row of 0 occurs means what? Poles are symmetrical about origin. Row of 0 occurs means poles are symmetrical about the origin. Row of 0 occurs means poles are symmetrical about the origin. Poles are symmetrical about the origin. Symmetrical about origin means it may be on the real axis, it may be on the imaginary axis. It may be on the real axis, it may be on the imaginary axis. Okay? But symmetrical about the origin. All the coefficients in the first column having same sign. It may be positive or negative. All the coefficients in the first column are positive or same sign. What is the meaning of all the coefficients in the first column same sign? All the coefficients in the first column are having same sign. That means what? That means what? No pole in the right hand side. That means no pole in the all are having same sign means no pole in the right. All the coefficients are same sign. Same sign. All are same sign. Same sign means no pole right. No pole right hand side. No pole right off. No pole right off. That means you should not place any pole right. We have to place a symmetrical poles at origin. That means what? Without placing a pole in the right, can you place a symmetrical poles on the real axis? Can you place the symmetrical poles on the real axis? It is not possible. Not possible. That means real axis is ruled out. Then where should be the poles? Once real axis ruled out, where should be the poles? It should be only on the imaginary axis. It should be only on the imaginary axis. But it may be repeated, na? It may be repeated. Even repeated poles on imaginary axis makes the system what? Unstable. So how can you say non-repeated? One time row of 0. One time row of 0 indicates non-repeated poles. Non-repeated poles which are symmetrical about the origin. One time row of 0. Non-repeated poles which are symmetrical about origin. That means what is the conclusion? Whenever only one row of zeros, only one row of zeros, all are having same sign in the first column, blindly we can say that the system is marginal stable because the poles lies on imaginary axis, which the poles lies on imaginary axis, which are non-repeated. Whenever only once row of 0 occurs, whenever only once row of 0 occurs, row of 0 occurs and all the coefficients in the first column are having same sign, then the system is marginal stable. Then the system is marginal stable because the poles lies on j omega axis, which are non-repeated, which are non-repeated. ठीक है? Right. And one more thing, be remember, auxiliary equation always consists only even power of s terms. Row of 0 always occurs odd power only. Row of 0 always occur odd powers only. Auxiliary equation consists only even power. You take any characteristic equation, you observe, you write it. Row of 0 occurs only odd powers, and auxiliary equation consists only even power of s terms. Okay. Auxiliary equation consists only even power of s terms. Be remember, auxiliary equation consists only even power. Consists only even power terms. Even power of s terms. Row of 0 occurs only odd power of s rows. Row of 0 occurs only odd power of s terms. Odd power of s terms. So be remember this also. Okay. Right. Next. Sri Charan, what is the doubt?
Sir, if the roots are repeated, why it is unstable, sir?
It will come. Wait.
Okay, okay, sir.
Right. Next. Repeated roots unstable. I told in the basics itself. Two poles at origin, you take what is inverse Laplace transform. I discussed very clearly in the basics. Today class you forget, but tomorrow, then what happened? 1 by s square inverse Laplace transform t. It is unstable. Repeated poles on imaginary unstable. I am discussed very clearly in the basics. Refer the basics in the first class or second class. Basics you should be very strong, man. I discussed it already. Again you are asking. One time row of 0. We discuss here only one time row of 0. One time row of 0. If the poles are repeated here, the poles are repeated, non-repeated. 2 times row of 0, 2 poles repeated. 10 times row of 0, 10 poles repeated. It will come, wait. Some more time you wait. Number of times rows of 0 is equal to number of poles are repeated. The system becomes the unstable. It will come. You wait some more time. Right, next, listen. Listen, one more thing, listen. So be remember, whenever only once row of 0, all the coefficients are same sign. Blindly we can say it is marginal stable because poles are coming on imaginary which are non-repeated. One time row of 0 means non-repeated. Next. See, I'll take one simple conclusion. Simple Routh tabular form I'll take. I'll take one simple Routh tabular form. Listen, all of you. Sample Routh tabular form I'll take. This is s power 5, s power 4, s cube, s square, s power 1, s power 0. So this is minus I'll take, plus I'll take, here row of 0 I'll take, again here plus, plus, for example here also plus, here also minus, here minus I'll take. This is a sample Routh tabular form. In case we got sample Routh tabular form like this. Then how the poles are placed? How many poles right? How many poles left? How many symmetrical about the? How many symmetrical about the origin? So that and all we want. Right. Listen. Listen, all of you. If you listen, then only you will get. If you don't listen, you don't get. Listen. One time row of 0. One time row of 0. Means what? One time row of 0 means what? Poles are symmetrical about origin. Symmetrical about origin, which are non-repeated. Which are non-repeated. Which are non-repeated. Okay. One time row of 0 means poles are symmetrical about origin, which are non. How many poles symmetrical about origin? What is the auxiliary equation order? Fourth order. That indicates what? Auxiliary equation order S power 4, fourth order. That indicates what? 4 poles symmetrical about origin. 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 So 4 poles you have to place symmetrical about the origin. 4 poles you have to place symmetrical about the origin. Okay. Now below auxiliary equation, above auxiliary equation concept will come. Below auxiliary equation. So below auxiliary equation. So any coefficient, any value, any sign change you are writing, that belongs to auxiliary equation only. That belongs to auxiliary equation. If any sign change occurs below auxiliary equation, if any sign change occurs, any constant, anything you are writing below auxiliary equation, that belongs to auxiliary equation only. That belongs to auxiliary equation only. How the auxiliary equation poles? Symmetrical about origin. For example, here below auxiliary equation, there is one sign change. Below auxiliary equation, there is one sign change. That means this one pole belongs to auxiliary equation only. This pole should be placed in the right. That pole belongs to auxiliary equation only. One sign change means one pole. Total how many poles symmetrically you have to place? 4 poles you have to place symmetrical about origin. We required to place a 4 poles symmetrical about the origin. We required to place 4 poles symmetrical about origin. In a 4 poles, how many sign change is there? One sign change. That means one pole should be placed in the right. One pole should be placed in the right. But this pole should have a symmetrical pole. Why? Because this pole belongs to auxiliary equation. Auxiliary equation poles are what? Symmetrical about the origin. Symmetrical about the origin. That means what? This pole belongs to auxiliary equation. This pole should have a symmetrical pole in the left hand side. Symmetrical pole in the left hand side. Symmetrical pole left hand side. Because this pole belongs to auxiliary equation. So auxiliary equation poles all are should have symmetrical poles. Auxiliary equation poles should have symmetrical. One sign change, one pole right. Because it is below auxiliary equation, it should have symmetrical pole in the left hand side. Symmetrical pole in the left hand side. Total how many poles completed? 2 poles. How many poles symmetrical? 4 poles. That means remain 2 poles where it should be on imaginary axis. Remain 2 poles must be imaginary axis. First you have to place sign change poles. First you have to place below auxiliary equation sign change poles. Below auxiliary equation sign change poles. One sign change, one pole right. Because below auxiliary equation symmetrical pole in the left. 2 poles completed, but total 4 poles symmetrical. Remain whatever the number is there, that you have to place on imaginary axis. That you have to place on imaginary axis. Total now tell how many poles symmetrical about origin? 4 poles symmetrical about origin. That means auxiliary equation poles are completed. Now above auxiliary equation, there is one sign change. Above auxiliary equation, there is one sign change. That means that one pole should be right. Above auxiliary equation, there is one sign change. That means that one pole should be right. But there is no symmetrical pole in the left hand side. There is no symmetrical pole in the left hand side. That means what is the conclusion? This sign change occur below auxiliary equation should have a symmetrical pole in the left hand side. Symmetrical pole in the left half to the pole placed in the right. to the poles placed in the right. Placed in the right. Placed in the right. So this sign change occurs below auxiliary equation should have symmetrical pole in the left to the pole placed in the right. For above auxiliary equation, no symmetrical pole in the left. No symmetrical pole in the left. No symmetrical pole in the left of to the pole placed in the right. To the pole placed in the right. To the pole placed in the right. Placed in the right. Above auxiliary equation, no symmetrical pole. Below auxiliary equation, compulsory symmetrical pole is there. So what is the conclusion? The sign change occurs below auxiliary equation. The sign change occurs below auxiliary equation. Below auxiliary equation should have symmetrical pole in the left. Symmetrical pole in the left to the pole placed in the right. To the pole placed in the right. The sign change occurs above auxiliary equation. The sign change occurs above auxiliary equation. The sign change occurs above auxiliary equation. There is no symmetrical pole. There is no symmetrical pole in the left. Left of to the pole placed in the right. To the pole placed in the right. In the right. Okay, be remember this. For example, one more thing I'll take. One more thing I'll take. One more thing. Sample Raut tabular form I'll take. You answer for this. S power 5, S power 4, S cube, S cube, S plus row of 0, one time row of 0, plus here also plus, minus plus. Come on, tell the answer. Tell the answer, all of you, come on. What is the order of auxiliary equation? Auxiliary equation order, fourth order. That means 4 poles symmetric about origin. You have to place 4 poles symmetric about origin. One time row of 0 means poles are not repeated. Next, below auxiliary equation. How many sign change? Below auxiliary equation, 2 sign changes. Means 2 poles right. 2 poles right and symmetrical poles left. Come on, represent it. Represent, come on, 2 poles right. 2 poles right, which are non-repeated like this. And symmetrical poles should be in the left. So like this. Symmetrical poles should be in the left. Now total how many poles completed? 1, 2, 3, 4. 4 poles. So 4 poles only symmetric about origin. That means all the poles completed on the real axis itself. Then how many poles on imaginary? No pole on imaginary. After placing a poles on the real axis, anything left, then only on imaginary. If nothing left, no pole on imaginary. Here, no pole on imaginary. No pole on j omega axis. On j omega axis. No pole, because all are completed on real axis itself. Fifth pole, no sign change, na? That fifth pole will come in the left hand side, because no sign change above auxiliary equation. No sign change above auxiliary equation. So fifth pole in the left. So like this, you have to identify number of poles. So 2 poles right, 3 poles left. 3 poles left. No pole on imaginary axis. So first case, what I taken? What I taken first case? So only one time row of 0. One time all are positive means it will come imaginary. One time row of 0, one sign change means one pole right, symmetrical left, remains should be on imaginary. So two sign changes mean 2 poles right and symmetrical left. So that if anything left, will place on the imaginary. Nothing left, no pole on imaginary axis. Below sign changes, symmetrical pole. Above auxiliary equation sign change, no symmetrical pole on imaginary axis. Okay. So take the break. After the break, I'll continue. Take the break. Okay. After the break, we'll take the repeated poles. So 2 times row of zeros I'll consider. Okay. We'll discuss after the break. Take the break. Right. Okay. Right. Here, one more thing in this problem, two sign changes na, two poles right na, two poles right na. So two poles right means it may be even complex conjugate also. This is also correct. Or two poles right. In RH criteria, main disadvantage is, in RH criteria, main disadvantage is we cannot identify the location of poles. Simply we'll say two poles right. But that is on real axis or complex conjugate, that we cannot decide. So that's why even we can place like this also. This is also correct. This is also correct. Here also two poles right and symmetrical poles are in the left hand side. This is also correct. This is also correct. And one more pole in the left. So this is also correct. This is, both are same. According to RH criteria, both are same. Two sign chains, two poles right, symmetrical poles left. And no pole on imaginary. So no pole on j omega axis. One more pole in the left hand. Okay, one problem. Next, one more problem. Characteristic equation. S power 6 plus 3s power 5 plus 4s power 4 plus 6s cube plus 5s square plus 3s plus 2 equal to 0. Come on, do it. All of you do it. Come on, solve, Guruji. All of you solve it. Come on. S power 6, 5, 4, 3, 2, 1, 0. Come, solve it. Here 1. Anybody answer? Four poles on j omega which are repeated. 2 times row of zeros. Come on. Right. 1, alternate term 4, alternate term 5, alternate term 2, 6, 4, 5, 2. Sorry, 1, 4, 5, 2. Next. Year 3, alternate 6, alternate 3. 3, 6, 3. Next, come on, get the answer. Next, get the answer. Next, S power 0 coefficient. This one, shift diagonal. Then year 2. Next, 12, 3 into 4, 12. 12 minus 6, 6. 6 by 3, 2. Next, 15, 3 into 5, 15. 15 minus 3, 12. 12 by 3, 4. 12 by 3, 4. Next, 2 into 3, 6, 12. 3 into 4, 12. 12 minus 12, 0. Next, 6 minus 6, 0. So here already 0 is there. 0, 0 is there. So 2 into 0, 3 into 0, 0. So now what happened? One time, first row of 0. First row of 0. Now what I told, this should be S power 4. This is S square. This is S power 0. Replace 0 by power into coefficient. 2 into 4, 8. 2 into 4, 8. 2 into 0, 0. Next, S square coefficient. So 8 4 is 32. 32 minus 16. 16. 16 by 8, 2. Next, S power 0 coefficient. Shift the diagonal. Next, 16 minus 16, 0. Here again, 0. So, second row of 0. Next, here, S square. Here, S power 0. Here, 4. Here, 2. Here, 2. That's all. So that means how many times row of 0 occurs? 2 times row of 0 occurs here. 2 times row of 0 occurs. Na? So this is first row of 0, second row of 0. 2 times row of 0 means 2 poles are repeated. This is the first auxiliary equation. This is auxiliary equation 1. So this is second. Never consider the second auxiliary equation. Never consider the second auxiliary equation. This is second auxiliary equation. Never consider. This shows just repeated nature of the poles. Repeated nature of poles. Repeated nature of poles. So for example, consider only first auxiliary equation. What is that tell? 2s power 4 plus 4s square plus 2 equal to 0. This can be written as what? S power 4, 2s square plus 1 equal to 0. Then what is the auxiliary equation tell? S square plus 1 whole square equal to 0. S equal to what? Plus r minus j1 comma plus r minus j1. Plus r minus j1 comma plus r minus j1. That means what happened? Poles are repeated. How many poles repeated tell? 2 poles repeated. Plus r minus j1 plus r minus j1. Why 2 poles repeated? Because 3 times row of 0. Sorry, 2 times row of zeros. So 2 poles are repeated. So system what? Unstable. Repeated poles mean T term present. T term means unbounded term. So that's why system unstable. Repeated poles on imaginary axis. Repeated poles repeated poles on j omega axis. J omega axis. System unstable. System unstable. Remain two poles. Above auxiliary, no sign change. That means remain two poles should be left. System is unstable. Whenever many times row of zero occurs, blindly we can say that system is unstable. Many times row of zero occurs. Many times. Two times row of zero means two poles are repeated. N times row of zero means n poles are repeated. Means n poles are repeated. N poles are repeated. N poles are repeated. N poles are repeated. Okay. Whenever many times row of zero occurs in the Routh tabular form, system unstable. Whenever many times row of zero occurs and all the coefficients in the first column positive and all the coefficients in the first column are same sign. Same sign. System unstable. System is unstable. System unstable. Yes means unstable. Unstable because poles are imaginary. Because poles on j omega axis which are repeated. So many times row of zero occurs means the system automatically what? Unstable. The system automatically unstable. Okay. That's all. The system is unstable. Okay. Next problem. Why minus 2s square? It is plus 2s square only. Why will get minus 10? 32 minus 16, how much? 16 positive only. Calculate correctly. Don't get negative. Next problem. So what is the conclusion? Whenever many times row of zero occurs, blindly we can say that system is unstable because poles are repeated on the imaginary axis. So system is unstable. Next, one more problem. Find the number of poles in the right of S plane. Find the number of poles in the right of S plane. Characteristic equation s power 4 plus s cube minus s minus 1. Come on, do it. Come on, Bhaiya, come on. So here, come on. S power 4 plus s cube minus s minus 1 equal to 0. One pole right. Unstable. By looking itself, we can tell it is unstable because missing coefficient is there and sign change is there. By looking itself, we can tell unstable. But what is the question? How many poles in the right? Whenever they ask the poles in the right, there is no alternate other than RH criteria. Whenever they ask poles in the right, there is no alternate other than RH criteria. Yeah. Come on, do it. S power 4, S cube, S square, S power 1, S power 0. Come on, 1. Alternate 0, S square not there, minus 1. Then 1, S power 1, minus 1. Then this S power 0 coefficient, whatever, just shift the diagonally. Here minus 1. Then here 1 into 0, 0. 0 into minus of minus 1 means 1. Here you'll get the 1. Next, come on. 1 into minus 1, minus 1. Minus of minus 1 becomes 0. Here 0. Then what happened? 1 time row of 0. 1 time row of 0. Then this is what? S square. This is what? S power 0. That means here 2. Then this is shift diagonally. Here it become minus 1. So now tell how many sign change in the first column? Only 1. So what is the order of auxiliary equation here? Order of auxiliary equation. Auxiliary equation order is what? Second order. Second. So that means 2 poles symmetric about origin. 2 poles symmetric about origin. About origin. 2 poles symmetrical about origin. In a 2 poles, how many sign change below auxiliary equation? Below auxiliary equation, we are having 1 sign change. We are having 1 sign change. We are having. This is 1 sign change. That means 1 pole is right. Below auxiliary equation, 1 sign change. That means 1 pole is right. 1 pole is right. 1 pole right. But it belongs to auxiliary equation. Below auxiliary, symmetrical pole should be in the left. Symmetrical pole should be in the left. Then auxiliary equation. Then how many poles are imaginary? No pole on imaginary. No pole on imaginary. Because auxiliary equation order second order. Second order means 2 poles only symmetrical. The 2 poles already lies on the what? Real axis. 2 poles already is there on the real axis. So no more. 2 poles only symmetric. 2 poles already placed symmetric. So that no pole on imaginary axis. Above auxiliary, no sign change. That means that pole should be in the left hand side. So 1 pole right, 1 pole right, 3 poles left. 3 poles left. 3 poles. System unstable. System unstable. See, only 1 time row of 0 means, and 1 sign change means 1 pole right and symmetrical pole in the left hand. Row of 0 is there means symmetrical poles will get. If you want to write auxiliary equation, what is there? What is the auxiliary equation? Tell second order only, na? S square minus 1. S square minus 1 equal to 0 is auxiliary equation. What is S? Tell S equal to what? Plus or minus 1. 1 pole here plus 1. Another pole minus 1. Is it symmetric or not? So automatically we'll get the symmetrical pole. Row of 0 is there means symmetrical pole automatically will get about the origin. Next problem. Next problem. Jivika Tiwari.
Hello.
Tell
Yes.
past.
Sir, can we solve this question by taking zeta is small positive constant? Because in
Why small row of 0 is there, na?
Sir, row of 0 occur, but here we neglect the last row because
How
it
can
is
you
not.
neglect? You should not neglect it.
Sir, because it is occur in S1 row, and S1 row only
You should
S1
not
coefficient
neglect. You
exists.
should not neglect. You should not neglect. Row of 0 is there means row of 0 you should take. That's all. How can you neglect? You should not neglect.
Okay.
Okay. Right. Next. Right. Next one. Write it. Next question. Identify the Routh tabular form. Identify the Identify the Routh tabular form. Identify the Routh tabular form to the given poles locations in the S-plane. To the given poles locations in the S-plane. To the given poles locations in the S-plane. Come on, do it. Come on, do it. What is the expected Routh tabular form? Anybody answer? Two row of zeros will be there. Fourth order auxiliary equation. Very good. Listen, simple logic. What is the four poles are symmetrical about origin? Four poles symmetrical about origin. Poles are not repeated. Poles are not repeated. That means one time row of zero. Four poles symmetrical about origin. Four poles symmetric about origin. So auxiliary equation order, fourth order. One pole in the right of S-plane. One pole in the right of and symmetrical pole in the left. Symmetrical pole in the left. That means one sign change below auxiliary equation. One sign change below auxiliary equation. That's all. Now check it, either it is correct or not, you check it. So how to check? You take the location of the poles, any value. You take a value to the, you assign a value to the pole and then check it. For example, I will assign a value here. This I'll take plus J1, sorry, plus 1. This should be symmetric pole, -1. This I'll take plus J2 minus J2, or for easy calculation, I'll take plus J1 minus J1. These two symmetric, these two symmetric you should take. You want to take here plus J5 minus 2 plus 2, any value you take. Routh tabular form not going to be changed. Values will change, but Routh tabular row of zeros, so sign changes are not going to be changed. So now what is the characteristic equation tell? Characteristic equation tell? Characteristic equation. Come on. Poles on imaginary. What is the characteristic equation? S square plus 1. S square plus 1. Poles on real. What is the terms you write now? Characteristic equation. Term. What is the term tell? Pole left S plus 1. Pole right S minus 1. Pole on imaginary S minus J1. Pole on negative imaginary S plus J1 equal to 0. Become characteristic equation. So this can be written as what? S square minus 1 and S square plus 1. This can be written as what? s power 4 minus 1 equal to 0. So like this you can, and we can check this answers either correct or not. We can check the answers either correct or not. How to check? Write the Raut tabular form. This is s power 4. This is s cube, s square, s power 1, s power 0. Now tell this is 1, s square 0, minus 1, s cube 0, 0, 0. Then what happened? Row of 0 occurs. What happened? Entire row become na? One time row of 0 occurs. One time row of 0 occurs. Then what happened? Tell. Here s power 4, s square, s power 0. This will become 1 into 4, 4. 0 into 2, 0. 0 into minus 1, 0. Next tell. 4 into 0, 0. Minus 0. So that means here 0. Next here, this is minus 1. Minus 1. Shift the diagonally. Here minus 1. Shift the diagonally. Here minus 1. Here replaced by epsilon. Epsilon into 0. Epsilon into 0, 0. 0 minus of minus 4 means 4. So 4 by epsilon. 4 by epsilon. So is it positive or not positive? It is plus infinity. Now tell one time row of 0. Auxiliary equation order, fourth order. Just verification, that's all, not required, but for our satisfaction, fourth order. So one time row of 0, auxiliary equation order, fourth order. And how many sign change? One sign change below auxiliary equation. One sign change below. So all the statements correct or not? One sign change below auxiliary equation. So one sign change below. So all the statements are correct. So in the exam, they are giving like this poles location. They are giving a statements. Pick up the correct statement. Poles are repeated. Or one time row of 0. One time row of 0. One sign change above auxiliary equation. One time row of 0. One sign change below auxiliary equation. Two time row of, like that statements are giving. If you have any doubt like this, values you select and then apply and then get the answer. Okay, na? Next problem. For example, I will remove this pole. What should be the expected Raut tabular form? Next, for example, repeat the above problem. Repeat above problem. Come on, do it. Completed? Completed, Guruji? One row of 0, one sign change above auxiliary equation. Very good, very good. Good, good, good. Many students are written correct answer. Very good. So, right. See here. What is the answer? One time row of 0. One time row of 0. Because poles are symmetrical. Two poles are symmetrical. Two poles are symmetrical. Symmetrical. About origin. About origin. So auxiliary equation order is second order. Auxiliary equation second order. And one sign change above auxiliary equation. One sign change above auxiliary equation. Above auxiliary. Because no symmetrical pole in the left. Because no symmetrical pole in the left. No symmetrical pole in the left. Left of S plane. No symmetrical pole in the left of S plane. That's all. So now if you have any doubt, you take this is plus J1 minus J1 plus 1. Come on, write the characteristic equation. So what I will get? S square plus 1 for imaginary poles, S minus 1 for real poles. Then what is the characteristic equation tell? S cube minus S square plus S minus 1 equal to 0. Then write the Routh tabular form. S cube, S square, S power 1, S power 0. So then what I will get? 1, 1, minus 1, minus 1, then minus 1 plus 1, 0, row of 0, 1 time row of 0. Then this will become what? S square. This is S power 0. This is minus 2. Then this become minus 1. So below auxiliary, is there any sign change? Check it. All are minus, no sign change. But above auxiliary, one sign change here. One sign change. Above auxiliary, one sign change above, 1 time row of 0, auxiliary equation order. So like this, we can write the Routh tabular form. One more question is solved. One more question. Repeat the above problem. I'll take 3 times row of 0. I will take 3 poles are repeated, not 1 pole. 3 poles are repeated. Three times row of zeros. 6th order auxiliary equation. Come on, check it, all of you. Check it, either it is correct or not. Check, are you really are getting 3 times row of 0 or not? Some people asking doubt. Come on, check it. Plus or minus J1. You take and write auxiliary characteristic equation and check it. Are you getting really 3 times row of 0 or not? Come on, Guruji. Some people asking doubt. What is the auxiliary equation tell? Answer is 3 times row of zeros. 3 times row of zeros. And all the coefficients in the first column positive. And all the coefficients in the first column first one are same sign. Come on. What is the characteristic equation? S square plus 1 whole cube equal to 0. Then what is the characteristic equation? S power 6 plus 3, S power 4 plus 3s square plus 1 equal to 0. A cube plus 3a square b plus 3ab square plus 1 plus b cube. Write the Routh tabular form. Come on, write the Routh tabular form. Come on, Guruji, come on. So S power 6, 4, 5, 4, 3, 2, 1, 0. S power 6, 1. next 3, next 3, next 1, next s power 5, 0, s cube 0, s power 1, 0, 0. So that means what? First row of 0. Next, this is s power 6, s power 4, s square, s square. Now what happened here? 6. Here what happened? 12. Here what happened? 6. Here 0. Continue the route stability. Next bolo. Mudarla 18. 18 na? 18 minus 12. 18 minus 12 means 6. 6 by 6 means 1. Next 18 minus 6. 12. 12 by 6 means 2. This you shift diagonally. S power 0 coefficient. Shift the diagonal 1. Next 12 minus 12. 0. 6 minus 6. 0. 0. Second row of 0. This is s power 4. This is s square. This is s power 0. Then it is 4. Here also 4. Next. Come on. 8 minus 4. 8 na 8 minus 4, 4. 4 by 4, 1. 4 by 4, 1. Here this is shift diagonally. 1. 4 minus 4, 0. Here 0. Third row of 0. This is s square. This is s power 0. This is 2. This shift the diagonally. So what is the answer? 3 times row of 0. All the coefficients in the first column are positive. That's all. So like this, we can guess the route tabular form to the given poles locations. One small homework I'll give. You try to solve in your home. Okay. Completed na? All of you completed na? Right. Next problem. Homework you do it. Repeat the above problem. For example, I'll take 2 poles right like this. Symmetrical poles I'll take in the left. What is the expected route tabular form? Second problem. Two poles right like this. Symmetrical poles in the left. What is the expected route tabular form? Come on, what is the answer? Tell anybody. What is the answer? Same for both the things. Is it audible? One student put it not audible. Audible, na? Yes, giving response means audible only. Right. So, right. Listen. Next. So, for both the things same, what is the answer means? Solution for both the things is same. 2 one time row of 0. One time row of 0 and 2 sign changes below auxiliary equation. That's all. Okay. Next. One more problem. Note down the question. Right here, space not sufficient. I'll write in the next page. Right. Identify the number of poles in the left, comma, right, comma, on j omega axis. Identify the number of poles in the left, comma, right, comma, on j omega axis of the S-plane. S-plane to the given sample Routh tabular form. To the given sample Routh tabular form. S power 7, S power 6, 5, 4, 3, 2, 1. Next, plus row of 0 plus row of 0 plus minus plus. Come on, write the answers. Left 2, right 1, j omega 4. 0 poles on j omega. 2 poles symmetrical on j omega. Write all the statements, man. Then you will get the correct answer. Write all the statements. You write the statements. For example, how to write the statement? See, 2 times row of zeros. 2 times row of zeros means 2 poles are repeated. Two poles are repeated. Auxiliary equation order 6th. Equation order 6th. That means 6 poles symmetrical about origin. 6 poles symmetrical about origin. 6 poles symmetric about origin. Next, below auxiliary equation. 2 sign change occurs. 2 sign change. Below auxiliary equation. That means 2 poles lies in the right. And symmetrical poles in the left. That's all. First place these 6 poles. You place these 6 poles, come on. All the 6 poles you place it first. All the 6 poles you place. Come on. First 2 poles right. So 2 poles right I'll place like this side. For example, first I'll place like this. For example, 2 poles right. Then symmetrical poles left, for example. It is not correct, just listen. Symmetrical poles in the left. Symmetrical poles in the left. Now, total how many poles completed? 4 poles completed. 1, 2, 3, 4. But how many poles symmetrical? 6. Remain 2 poles must be on imaginary axis. Remain 2 poles must be on imaginary. Now tell all the 6 poles are symmetrical about origin. Correct. This is correct. And 2 sign changes. This is also correct. This is also correct. But what about these 2 poles are repeated? Na? Where it should be repeated? Can you repeat on imaginary? It is not possible because only 2 poles are there. If you want to repeat 2 poles at a particular point, because of symmetry, 4 poles required. If you 4 poles are there on imaginary, I might have repeated. But where are the 4 poles? On the real axis we are having. So in the real axis, instead of representing separately, we can repeat here. 2 poles I'll repeat. 2 poles I'll repeat. Now tell 2 poles right. Symmetrical poles left. Total 6 poles are symmetrical about origin and 2 poles repeated. 6 poles symmetrical and 2 poles in the right side. And 7th pole, no sign change, it is in the left. So 7th pole is left. That means answer is 2 poles right, 2 poles imaginary, j omega, 3 poles left. This is the answer. Okay. One more problem. Repeat the above problem. S power 7, 6, 5, 4, plus, plus, plus. Come on, do it. Come on. So what is the answer? Left 3. You should not take any pole at origin. Don't take poles at origin. Never take a pole at origin. Be remember. Right. Left 3, right 4. Very good, very good, very good. Right. See, first one time row of 0. One time row of 0. Poles are not repeated. Poles are not repeated. Auxiliary equation order, fourth order. 4 poles symmetric about origin. Four poles symmetric about origin. Below auxiliary equation, 2 sign changes. 2 sign changes. Below auxiliary equation. That means 2 poles right and symmetrical poles left. Now represent this. First we represent this auxiliary equation poles. Come on. So total 4 poles. Symmetric about it. In 4 poles, 2 poles right. So 2 poles right, which are non-repeated. So symmetrical poles in the left. Four poles completed. 4 poles only symmetric about origin. Na? So 4 poles completed. Next, above auxiliary equation. How many sign change? 2 sign changes. Each row 1 pole. Each row 1 pole. And total how many poles? 1, 2, 3. 3 poles. In a 3 poles, 2 sign change means 2 poles right. In a 3 poles, 2 sign change. That means 2 poles right. So 1 pole left. 1 pole left. Each row 1 pole. 3 rows, 3 poles. So 3 poles. In 3 poles, 2 sign change. 2 poles right, 1 pole left. So answer is what? 4 poles right, 3 poles. That's all. Like this, you have to identify the what? Number of poles in the right, comma, left, comma, on imaginary axis. Next, we have to start the conditional stable systems. So that will solve in the next class. Conditional stable system, relative stability. That and all we'll discuss in the next class. If you have any doubt, you ask me. If you have any doubt, you can ask. Still 3 minutes is there. Okay, no problem. Happy Deepavali to all. Don't fire the crackers. Celebrate real Deepavali by gaining the knowledge. Okay. If you have any doubt, you can write the hand. Susmita.
Good evening, sir.
Good evening, Chapamma.
Sir, relative stability, మీరు మనకి
It will come in the next class. Now I'll solve the problem.
ఓకే కాదు సార్ అంటే మెయిన్లీ టు ఫైండ్ ద టైం కాన్స్టెంట్ అని చెప్పారు కదా సార్
Closed loop time constant.
ఓకే ఓకే సార్ అదే అదే క్లోజ్డ్ లూప్ అదే అందుకే డౌట్ వచ్చింది సార్
Okay, అమ్మా. Okay. Okay. Next, Abdul.
సార్ ఇదే సార్ ఈ ప్రాబ్లం లో మనకి ఇక్కడ 3 పోల్స్ లెఫ్ట్ ఎలా వస్తుంది సార్ 4 పోల్స్ రైట్ అంటే 4 ఇది
Below auxiliary equation, how many sign change? 2 means 2 poles right, 2 poles left. Above auxiliary equation, how many sign change?
2.
Total how many poles above auxiliary?
2.
3 na? 1, 2, 3. 3 rows. 1, 2, 3. 3 poles.
3 poles.
In 3 poles, 2 right means 1 is left. Okay. Next. Naga Nitesh.
గుడ్ ఈవినింగ్ సార్.
Good evening, చెప్పమ్మా.
సార్ బిఫోర్ ప్రాబ్లంలో ఇమాజినరీ యాక్సిస్ మీద ఎందుకు రిపీట్ చేయదు సార్ పోల్స్? ఇమాజినరీ యాక్సిస్ మీద పోల్స్.
Imaginary axis, if we want to repeat, we required 4 poles. How many is there on imaginary?
1 pole.
How many is there on imaginary, man? Only 2 poles, na?
Yes sir, 2 poles.
If you want to repeat, how many poles required? If I want to repeat here like this, how many poles required?
4 poles sir.
Is there 4 poles on imaginary?
No.
Where are the 4 poles on real axis?
అర్థమైంది సార్. సార్ అలానే రిలేటివ్ స్టెబిలిటీ అప్రాక్సిమేట్లీ ఎందుకు తీసుకున్నాం సార్ అక్కడ?
Because RH criteria cannot give exact pole location.
ఓకే సార్. సార్ ఇది ఇంకోటి సార్, అంటే ఐ మీన్ సిలబస్ కదా సార్, ఇది మీరు 16th నుండి టైమింగ్స్ కొంచెం చెప్పగలుగుతారా సార్?
తెలియదు, నాకు తెలియదు, వేస్తా అని చెప్పాడు, నాకు అడిగాను నేను.
ఓకే సార్. అంటే
I asked him, so that he told I'll give full slot. He told it.
Yes sir. అంటే మాకు సెమ్ ఎగ్జామ్స్ అవుతున్నాయి సార్, అందుకని అడిగాను సార్ ఏ టైమింగ్స్.
I think it may be there from 2 to 7 or like that, I think.
అచ్చా, అంటే ఎగ్జామ్స్ అవుతున్నాయి సార్, సో అందుకనే కొంచెం కష్టం అవుతుంది సార్ ఏమన్నా టైమింగ్.
Some students are already, I think, only controls left. That is a big problem.
అచ్చా, ఓకే సార్.
They will send the video, recorded videos, na?
ఎస్ సార్, బట్ మళ్ళీ బ్రేక్ అవుతుంది సార్ సబ్జెక్ట్ అని అలా.
Try to attend it. We'll see how much time you will give the slot, na? Still not yet confirmed. Digital, when it is complete?
Digital not completed sir.
When it will complete?
Which one sir?
Digital.
No sir, not sir. మాకు పోయిన మంత్ స్టార్ట్ అయింది సార్.
50%, 78% completed?
No sir, batch మాకు పోయిన మంత్ స్టార్ట్ అయింది సార్. ఇదే ఫస్ట్.
Oh, batch itself last month started,
Yes sir.
Oh, that means still many subjects are there.
Yes sir, only maths aptitude అయిపోయింది సార్.
Next controls only.
ఇదే ఫస్ట్ సార్, మాకు ఎలక్ట్రికల్ లో ఫస్ట్ ఇదే సార్.
Oh, you are electrical,
Yes sir.
It is from only EC, na?
No sir, electrical sir.
You are from Delhi?
Not sir, Hyderabad.
Hyderabad only, na? Okay.
Electrical,
21
sir.
batch?
Sir?
2021 batch, 22 batch,
Yes sir, 22. Yes sir, 22 gate.
22 gate ante I think they'll go slowly. 22 batch means I think you can ask them, you can request them, manager,
Okay,
so
sir.
that second time when we'll teach, na, they'll allow to attend.
Okay sir.
You ask them, okay?
Okay sir.
Okay.
Thank you sir.
Right. Next, Naveen.
సార్ ఇక్కడ ఈ క్వశ్చన్ లో రిపీటెడ్ పోల్స్ తీసుకున్నారు కదా సార్ రియల్ యాక్సిస్ లో, ఇలా ఎందుకు తీసుకున్నారు?
2 times row of 0, na? 2 poles repeated.
ఓకే, అంటే విడిగా ఎందుకు తీసుకోలేదు సార్? అంటే సపరేట్ చేసి తీసుకోవచ్చు.
If you separate, if you take, then where the poles are repeated? If I said take it separate, how this statement satisfied, tell?
అవును సార్.
How this statement satisfy, The statement
Okay,
should be
sir.
satisfied or not?
ఎస్ సార్, ఇట్ హ్యావ్ టు
Then
సాటిస్ఫై.
compulsory you have to repeat it. Okay?
ఓకే సార్. అండ్
Amulya.
Good evening, sir.
Good evening,
Sir,
Chappan.
I just want to know why can't we take poles repeated at origin, sir?
You should not take at origin. Never take a pole at origin. If you take pole at origin, there is no meaning of symmetry about origin, na?
Okay.
If you take a pole at origin, there is no meaning of symmetry about origin.
Yes, sir. Yes.
You should not take it.
Okay. Thank you, sir.
Okay. Next, Abdul. Abdul.
ఏం లేదు సార్, అది అనుకోకుండా క్లిక్
అయిపోయిందా? ఓకే.
అయిపోయింది.
నెక్స్ట్, సుమంత్.
గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్, చెప్పమ్మా.
సార్, ఇదే క్వశ్చన్ సార్. అంటే నాకు డౌట్ ఏంటంటే ఇప్పుడు 2 times రో ఆఫ్ 0 అన్నప్పుడు 2 పోల్స్ రిపీటెడా లేకపోతే 2 times రిపీట్ చేయాలా సార్?
2 poles are repeated.
అంటే ఒకవేళ ఇప్పుడు రియల్ యాక్సిస్ మీద నాకు 6 పోల్స్ ఉన్నాయి అనుకోండి సార్.
Huh?
రియల్ యాక్సిస్ మీద ఐ హావ్ 6 పోల్స్, 3 ఆన్ రైట్ సైడ్ అండ్ 3 ఆన్ లెఫ్ట్ సైడ్. అప్పుడు ఓన్లీ 2 పోల్స్ నే రిపీట్ చేయాలా లేకపోతే
How many times row of 0? Based on that, you have to repeat.
అంటే ఇప్పుడు ఓన్లీ 2 పోల్స్ నే రిపీట్ చేయాలా సార్?
2 poles you have to repeat. Left side 2 poles you have to repeat. Right side 2 poles should be repeated. 2 times row of 0 means.
ఇంకా 2 పోల్స్ ఎలా ఉన్నా ఏం కాదు.
Remain what it may be here like this, nothing matter.
That's it, sir. Thank you.
Okay. Next. Naganitesh. Next, Krishna Vamshidhar.
Hello, sir.
Tell me.
Sir, can there be a characteristic equation without a constant? Can there be a characteristic equation
Then
without
it is
constant?
not stable.
Okay.
It will become marginal post stable because yes, we can take it common. Na?
Okay, sir.
Then it will become marginal stable.
Okay, sir. Thank you, sir.
Okay, na?
Yes, sir.
Okay. Next, Pratik Darla.
Sir?
Tell me.
Sir, ఇది ఓన్లీ యాక్సిస్ మీద తీసుకున్నారు కదా, అంటే నార్మల్ రైట్ సైడ్ ఎక్కడైనా ఉంటుంది కదా?
Right side anywhere. Right side means it should be repeated not on the real axis only. It should not be complex conjugate.
Okay.
The location is any. It may be +1, it may be +2, it may be +10. Whatever the location immaterial.
Okay.
But two should be in the right.
Complex conjugate అయితే
Complex conjugate not possible, na, because it is not repeated, na. Here 2 poles should be repeated, na.
Yes, sir. Yes.
Complex conjugate, how it is possible?
Okay, not this sum, sir. అంటే homework లో ఇచ్చింది.
You can repeat complex conjugate if in case 4 poles are there. 4 poles repeated means right side pole, left side 4 you can put it.
Okay.
Okay,
sir. Okay.
Next, Naganitesh Chinupunuri. No doubt working. I hope completed. Any doubts? Raise the hand.